Imagine I put a teaspoon on this table right now. Just one teaspoon. Small, light. You could hold it in your hand without even feeling it. Now imagine that teaspoon was filled with material from a neutron star. That teaspoon would weigh 1 billion tons. It would not just fall through the table. It would fall through the table, through the floor, through every layer of rock and metal inside the Earth, straight through to the other side of the planet. And it would keep going. Nothing we have ever built, no steel, no concrete, no material on Earth, could even slow it down. 1 teaspoon. 1 billion tons. That is not science fiction. That is a neutron star. And once I tell you how this thing actually forms, you will never look at stars the same way again. To understand a neutron star, you first have to understand what a normal star is doing every single second of its life. Our sun, and every star you see at night, is basically a giant explosion that never stops. Deep inside the sun, hydrogen atoms are smashing into each other millions of times per second, fusing together, releasing unimaginable amounts of energy. That energy pushes outward in every direction. It is the force that makes the sun shine. But here is what most people do not realize. At the same time, gravity is pulling everything inward, trying to collapse the sun, trying to crush it into a single point. So the sun is not just a ball of fire, it is a war, a non-stop battle between the energy pushing out and gravity pulling in. Every second of every day for billions of years, and right now our sun is winning that war. The two forces are balanced. Life exists on Earth because of that balance. But what happens when the war ends? Every star has a limited amount of fuel. It is burning through it slowly, but it is burning through it. After billions of years, a massive star, one much bigger than our sun, starts running out. The nuclear fire in the core begins to die down. The energy pushing outward gets weaker and weaker, and gravity does not care. Gravity never gets tired. Gravity never runs out. So the moment that outward energy weakens even slightly, gravity wins instantly. What happens next is one of the most violent events in the entire universe. The outer layers of the star, everything on the outside, they get pulled inward at incredible speed, millions of miles of star collapsing. In less than 1 second, all of that mass hitting the core, bouncing back, releasing more energy in that single moment than our sun will release in its entire 10 billion year lifetime. We call this a supernova, the biggest explosion in the universe. You can see a supernova from billions of light years away with your naked eye. It outshines entire galaxies, but after the explosion fades, what is left at the center? That is where things get truly insane. After the supernova, the core that remains is the most extreme object in the universe, short of a black hole. Gravity has crushed everything so hard, so violently, that the atoms themselves have been destroyed. Think about that. An atom has a nucleus in the middle, and electrons orbiting around it. There is actually a huge amount of empty space inside an atom, proportionally speaking. If an atom was the size of a football stadium, the nucleus would be the size of a pea in the center. A neutron star crushes all of that empty space out of existence. The electrons get forced into the nucleus. Everything compresses into a solid ball of pure neutrons, packed as tightly as physically possible. The result? A star the size of a city. Our sun is about 1.4 million kilometers wide. A neutron star is roughly 20 kilometers wide. That is smaller than most major cities. London, New York, Lahore. A neutron star would fit inside your city, but it still has the mass of the sun, sometimes 2 or 3 times the mass of the sun. All of that mass is in a ball 20 kilometers across. That is why 1 teaspoon weighs 1 billion tons. The density is so extreme that it is almost impossible for the human brain to actually process it. So let me try to make it real for you. Let us put a neutron star next to things you actually know. The Burj Khalifa, the tallest building on Earth, weighs about 500,000 tons. A single teaspoon of a neutron star weighs 2 million Burj Khalifas. Every single human being who has ever lived, all 100 billion of us, if you added up all our weight together, you would get roughly 750 million tons. 1 teaspoon of neutron star is still heavier than all of us combined, by a lot. Mount Everest, the entire mountain, weighs about 800 trillion tons. A neutron star packs that same kind of mass into the size of a neighborhood. And here is what really gets me. A neutron star is so dense, so massive, that its gravity warps the fabric of space around it. If you somehow got 10 kilometers away from one, you would need to be traveling at half the speed of light just to escape its pull. Half the speed of light. That is 150,000 kilometers per second. Nothing on Earth, no rocket, no machine we have ever built. Nothing even comes close. And some neutron stars do something even more incredible than that. When a neutron star forms from that collapsing supernova, something wild happens to its rotation. You know how when an ice skater pulls their arms in, they spin faster? Same physics. When a star that was slowly rotating suddenly collapses into something 20-kilometer wide, it spins up to incredible speed. Some neutron stars rotate 700 times per second, 700 complete rotations every single second. And as they spin, they beam out pulses of radio waves, like a cosmic lighthouse. We can detect those pulses from across the galaxy. They are so incredibly precise and regular that when scientists first detected them in 1967, they genuinely thought, in for a few weeks, that it was an alien civilization sending signals. They called the signal LGM-1, Little Green Men. It was not aliens. It was something in many ways more amazing. A neutron star spinning 30 times per second, so perfectly consistent that it functions as the most accurate natural clock in the known universe. More accurate than any clock humans have ever built. A dead star, spinning in the dark perfectly forever. A teaspoon, 1 billion tons. A star the size of your city, with the mass of the sun, spinning 700 times a second, in perfect silence. In perfect darkness, for billions of years. And here is the thing that stays with me. Right now, at this very moment, there are estimated to be over 1 billion neutron stars in our galaxy alone, sitting out there, dense beyond imagination, spinning, waiting. We have only discovered a few thousand of them. Drop a comment. Which comparison hit you the hardest? The teaspoon, the city size, or the 700 rotations per second? And if your mind is not done being blown, you stick around. Because next time we are talking about something that makes a neutron star look simple.